pressure, temperature. Okay, no. What I am asking you, go for PV graph and VT graph. So first of all, we should identify there's a PT graph is there, no? So let's go for ideal gas equation. What will happen to the here? You must come here, no? There's a what isobaric process. So as pressure increases, sorry, as temperature increases, volume should also increase. So VB greater than VA. So what is this? Isobaric heating. What is this? Isobaric cooling. What about these two? This is isothermal compression. This is isothermal expansion. Identifying each and every process. This is isothermal expansion. This is isobaric heating. Isobaric cooling. So this is isothermal. So that's why initially I plotted graphs, no? So the idea of that is very important. Okay, let's go for PT graph, no? First we'll go for volume versus temperature graph. No. Isobaric heating in VT graph. Straight line passing through origin. I'll bring like this. Okay, this will be I'm not very sure how the curve will be. Rough, I'm just trial and error it is. Okay, now what is BC? Isothermal expansion. In isothermal expansion, isobaric heating, okay, this is okay. Pressure, volume increases, temperature increases. Then isothermal expansion. Temperature constant, volume increases. I think this curve. Let me redraw it. It should come here. Okay, no. So this is the path AB. I'll give the number. Path AB. BC isothermal expansion. Temperature constant, volume will increase. Temperature constant, volume will increase. Next again, what is path CD? Isobaric cooling. So again, straight line passing through origin. Bring like this, and now bring the curve. Okay, now last one. Sir, how do you can? Is there any method? Okay, one thing I'll do identify one thing. What is that? Temperature at A equal to temperature at B. These are the very essential things, sir. Pressure at A equal to pressure at B. Pressure at D equal to pressure at C. Sir, regarding volumes, can you say anything about volumes? VB should be greater than VA. Will I agree? VC should be greater than VB. Sir, how do you can say? Okay, we'll do one thing. Isobaric process, isobaric heating, as temperature increases, volume should increase. So VB greater than VA. Got it, no? Okay, now come for isothermal expansion. In isothermal expansion, temperature will be constant, TB equal to TC. But volume will increase, so VC greater than VB. In isobaric cooling, so as pressure will be constant, so as temperature decreases, so even what mean volume should decrease. So therefore, what we can say regarding the volumes here, VD should be less than VC. So these are the things which will help us to plot the next graph. If you don't know this, not possible. We must have this basic information. Okay, let's go for the graph here. Okay, now what is the thing? There's a volume. Already volume plotted, no? Pressure versus volume, sorry. So there's a pressure. Now isobaric eating. So shall we put a straight line? Then afterwards, isothermal expansion. Then afterwards, isobaric cooling. So pressure constant, volume decreases. Then isothermic. And I'll give better graph. Straight line will take it here. Rectangular hyperbola. Let's see that are we right or wrong? Okay, this is the points A, B, C, D. Okay, the arrows will be like this here, previous one. Are we right or wrong? The shape of the curve. So we have to check it now. VB greater than VA, as it is. VC greater than VB. VD should be less than VC, no? So there's a small correction here. AB should be parallel to DC, isobaric process. What is isobaric process? Look at isobaric process. Pressure should be constant, no? None of the things are working. Okay, agree this. So these are the ways in which you have to learn. So next week, Otman will go in detail. There's an introduction, that one. So plotting graphs is not something like what you have to do. Each and every path, identify the process, and roughly you estimate. So you know pressure constant here. You know temperature increasing. What about the volume? If they give PT graph, search for volumes. If they give PV graph, search for temperature, because that will help us to plot the graphs. No? And you see some small information. PT graph, vertical line, isothermal process. PT graph, horizontal line, isobaric. VT graph, so VT graph, again, we can go for one more. VT graph, horizontal line, isochoric process. Like that, no, in every graph you identify. If you see a curve, PV graph curve, it should be isothermal. Okay, this will be very challenging because the student has to think here. We don't have any formulas, nothing. Student has to bring the basic geometry and the basic thermodynamics. Adiabatic isochoric process, what happened to pressure, volume, temperature. So very fast you recollect all this. There'll be much, this topic will be very easy for you if you can understand. Okay, this remaining problems I given, no, please do work out. First law of thermodynamics, okay, 1, okay, this 2. Yeah, 2 problems I left over here.